All right, so we're going to figure out all 6 trigonomic functions for this right triangle. Very important to emphasize that it's a right triangle because that's the only type of triangle you want to work on this with. And before we start getting into what all 6 of these functions are, it's important to recognize that we do not have our hypotenuse here. We do not have our C term in regards to A and B. So let's go ahead and figure out what C is. We have C squared is going to equal A squared plus B squared. But it really doesn't matter what your A and B are in this case in terms of where you put them. It's really just important to understand that this here needs to be by itself on the left side as C, and that's what we're solving for. So C squared equals 3 squared, which is 9, plus B squared, which is 25. Therefore, C squared equals 34, and we want to get C by itself, which means that you square root both sides, which means C equals root 34. Our hypotenuse here is simply root 34. There's no way to simplify that. There's no factoring or anything like that that we can do. So we've actually taken this as far as it can go. And now we can start getting into the 6 trigonomic functions that we came here to first figure out. Remember that there's SOHCAHTOA. So let's go over this first. SOHCAHTOA is just an acronym or a mnemonic device to help us remember what the functions are, and that is sine of theta. In this case, this is theta right here. All right. Sine of that angle, right? Sine of theta, I like to write it as x, is opposite over hypotenuse. And then cosine of that theta term is going to be adjacent over hypotenuse. And then tangent of that is going to be opposite over adjacent. So let's first write out what sine is. So sine of theta, in this case, is going to be opposite over hypotenuse, which means that sine of theta, in this case, opposite, which is right across, is going to be our 5 over our hypotenuse, which is root 34. All right. Sine of theta in this case is 5 over 34. All right. And now what we can get into is cosine. Cosine is just another setup that we'll have here as cosine of theta is adjacent. And in this case, adjacent is, you have technically 2 adjacents, right? When you think about the practical definition of adjacent, right? There's this term and then this term. But it's not going to be root 34 because root 34 we've already considered and deemed as our hypotenuse. So that must mean that our adjacent is going to be our blue 3 here. And then that is going to go over our hypotenuse of root 34. All right. And that this here now can be considered the answer for cosine. Oh, I was trying to do something fancy there. It didn't work out. So let me just rewrite it here. Cosine of theta in this particular question is now 3 over root 34. And now we can just solve for tangent. Tangent is going to be, tangent of theta is going to be opposite, so 5 over our adjacent, which is 3. And so this here can be now listed as tangent. I'm just going to keep this as blue, of theta equals 5 over 3. Might as well keep those on line. Okay, so now we can go into what cosecant, secant, and cotangent is. These are literally just terms that are the inverse or the reciprocal of the above mentioned trigonomic functions. So cosecant is just CSC of theta is just going to be the reciprocal of what we see here, which means that it's hypotenuse over opposite, which means that it's going to be cosecant of theta is going to be 34 or root 34 over 5. All right, so that's how you do these fancy words. Like they're scary at first, like cosecant, secant, and cotangent. but they're not really all that bad. It's just knowing that you have to reverse it. So that is cosecant. Okay, so let's go for secant. Secant, which would be written, so SEC of theta is going to just be hypotenuse over adjacent. So in this case, it will be secant of theta will be root 34 over 3. And then cotangent, we just keep with the same pattern. So cotangent is COT of theta is adjacent over opposite. So in this case, cotangent of theta is 3 over 5. So essentially the two main answers that we care about is this one here, sine, and here is its reciprocal, cosecant here. That's two functions right there. The other two functions would be here. These are their opposite answers. And then here is 5 and 6. And these two are going to bring us up to 6 trigonomic functions. Now, word of note, for these two right here, we notice that we have a radical in the denominator. So the way we would fix that is, let's write it out, where we have 5 over root 34, and that is sine of our theta. You want to remember that to rationalize our denominator, we just do root 34 over root 34. You're going to multiply by whatever that denominator is, or whatever the radical in the denominator is, over itself. So you end up with 5 root 34 over just 34, because anything under, because essentially what you have is 34 squared over the root, which just cancels each other out, and you just end up with that technically can be listed, or should be listed, as your sine of theta. And so let's do the same thing for cosecant, which is cosine over equals 3 over root 34. And then we times that by root 34 over root 34. And that will give us 3 root 34 over just 34. All right, so we didn't have to do that with our cosecants and all these here, because we see that they're just simply the inverse of that. I wanted to do those first, but then show you that this is the proper way that your teachers will be looking for. Best of luck on your exams.